When looking at combining like terms, one of the most important things is that they must have the same pronumeral and the same base. Two really important things to remember. Let's turn what we see here in the picture into an algebraic equation. You can see there that we have 3 basketballs. So I'm going to let the basketballs be equal to B. Let's say that we were adding or counting how many basketballs we'd have. We would add them together. Because they are all alike, they are like because they have the same pronumeral and the same base means that they have the same power. So we don't need to worry about that because they don't have a power. So they have the same pronumeral or the same base. That means that we can combine these like terms. So B plus B plus B. How many B's do we have? We have 3B, or 3 basketballs. This question we've got the hard hats representing the pronumeral. So let's go and put a pronumeral in there. I just like to use objects because it's good to think of when combining like terms that they're the same object. So 12 hats, take away 4 hats. So we might have had 12 hats and then 4 workers have gone and taken them away to go and use them. How many are left? We must look to see that they have the same pronumeral. They do. And if they're the same base. So yet again, no powers, so we don't need to worry about that. Same pronumeral, we can combine the like terms. This time we're combining them by taking them away. So 12H take 4H is equal to 8H. Or 12 hats take 4 hats is equal to 8 hats. Let's look at some of these pairs and see if they are like terms. Remember, we are looking for same pronumeral and same base. Look at the first one. We have A and A, same pronumeral. Is the base the same, meaning the power? There is no power, so tick. They're like terms. We could combine them, add them, subtract them. Next one, X and Y. Is it the same pronumeral? Well, straight away, no. Not like terms. Let's look at the next one. M cubed, or M to the power of 3, and an M by itself. They have the same pronumeral, so they're both M, but they don't have the same base. This one is cubed, or to the power of 3, meaning M times M times M. This is just one M on its own. So therefore, not like terms. Next one, AB and AB. Do they have the same pronumerals? Yes, they do. It's an A and a B and an A and a B. Technically, there's a little multiplication symbol in between those. We don't often show that with algebra. But, same pronumerals, A and a B, same base. There was no bases, so A and B are like terms. Let's look at this one. This one's interesting. E, F, and FE. Do they have the same base? Yes, there's no powers in this one. We don't need to worry. Do they have the same pronumeral? Well, yes. They both have an E, and they both have an F, but they're flipped around. Does that matter? No, it doesn't. Same as the first one. Technically, they're both getting multiplied by each other, EF and FE, so it doesn't matter as long as they've got the same pronumerals in there and the same base, then it doesn't matter which way you have it, whether it's EF or FE, the order doesn't matter. They're like terms. You could add them together. If I was adding them together, that would end up as 2EF, or you could write it as 2FE. They are both the same thing. Next one, 3XY and 12XY. The key with this one to remember is it doesn't matter if there is a coefficient, a number before the pronumerals. As long as the pronumerals are the same, which they are, and they have the same base, then they could be combined. So they are like terms. So therefore you could have added those together, for example, and it could have been 15xy. Last one, we have 15, 12. We don't need to worry about the coefficients. Let's have a look at this one. We have m squared and m. Same pronumeral, different base. So already not going to work. See with the other one, k and k to the power of 7. Same pronumeral, different base. So there's two reasons why these are not like terms either. Finally, here's some examples just with pronumerals and coefficients. First one, let's look at, I like to try and group like terms first. You can see that in the first question though, they're grouped together, meaning that they're all next to each other. M plus m plus m plus m. How many m's we have? We have 4 m's. Then we're adding on k and k, giving us 2 lots of k, and it is a positive k. So that is that equation solved. This one, I think it's an important habit to get into grouping the like terms. So first, I want you to put terms next to each other that are the same. So 12m plus 6m. So we're just rewriting the equation. 3a and 9a are the same as well. So 3a and 9a. Then it makes it easier for us to go and combine them. 12m plus 6m is equal to 18m. Positive 3a plus 9a is equal to 12a. So that is that equation simplified with like terms. Remember, if you have any questions at all or something that needs clarification, please make sure you come and see me throughout the lesson.